So let me give you something to make your life easy for showing this limit. Um, if you like lemma, you can use this. Suppose you have gamma r pz over qz dz, where p uh, is a polynomial of degree n and q of degree m, but bigger than n plus 2. Okay, okay. Then um, gamma r pz over qz goes to 0. Goes to 0 as 1 over r. Okay, all right. And let me do a quick proof. So as in the example, we do polar. So if you do polar coordinates, p I theta, q I theta with r. Okay, do your triangle and expand. So you have Rn with lower powers and Rm with lower powers, R d theta. Okay, so then again, I won't go into the details, but if you do reverse triangle, you get um, you get your Rn plus 1 lower order terms, and then Rm lower order terms. But in the limit, all it matters is the highest order. So let me say that here. By L'Hopital, you can just look at the highest order. So you have m minus n plus 1, but m is bigger or equal than n plus 2. So this is, is r less than r, which goes to 0. Okay, all right. Um, okay, let me do one more example and that's it. Just to showcase this lemma. Evaluate PV x squared plus 1 squared. Okay, so this is a ratio of polynomials. First complexify. So we have c and then z squared plus 1. Okay, good. Right, we split as usual the function and the semicircle. Okay, so now let's look at this guy. Let's just apply the lemma. P is z squared, q is z squared plus 1 squared, has degree 2, and this guy has degree 4, which is bigger or equal than 2 plus 2, n plus 2. Okay, So the lemma applies. The lemma applies to give, um, to give that z squared plus 1 squared dz goes to 0 as r goes to plus infinity. Okay, so this guy is out. We can ignore it. Now what you have is you have principal value of your integral f of x. Uh, okay, and now we have to do residue, and that's it. So we have this contour c, z squared plus 1 squared dz. Okay, so let's do residue. So 2 pi I residue of what? So we have to find the poles. Let's factor this. So we have z minus I squared. Let me write inside. So the poles are minus I and plus I. Okay, and here's the contour, and here's the pole, the two poles. But the only pole that matters is the one inside. So we only have a single pole at z equal I. So f of z at I, and that's it. There is no other pole. And as you can see, it's order 2. Okay? Alright, because I want to keep going with this, let me just write down what you have to evaluate, and I will evaluate for you. So z squared, so z minus I squared, z squared. So you take one derivative because it's order 2, and you evaluate at I, and long story short, you get pi over 2. Okay? So the principal value of our integral, so the limit of this is pi over 2. Okay, thank you. Actually, let me write it here. So minus infinity, infinity is equal to pi over 2, which is incredible. Okay, thank you.